If you'll remember, what I told you on Friday was that if you had 2 moves, then we were going to do it by hand. If you had more than 2 moves, we're going to let you use your calculator, okay? So everybody's got your calculator, right? All right. So I want you to look at this, -4 raised to the x minus 2 power. Let's decide what transformations are happening. What does that negative do? Reflects over? So we know we have a reflect over x. Now notice up here in the exponent, you have a -2 with the x. What does that do? Right 2. Yep. Questions there? All right. If I took off the reflect over the x-axis and the right 2, what would I be left with here? 4 to the x. Bless you. I would be left with y equals 4 to the x. So what I'm going to do is I'm going to make some points that are on that. Okay? Come on. There we go. Now we're going to use our same numbers. Use those for x, okay? What's 4 to the second power? Keep going. Keep going. You tell me when you're having trouble. Now we're going to take those and we're going to do the transformations. Now, what does reflect over the x-axis do? Switch what? No. Now look, if I had a point right here and I reflected it here.
Flip the sign of the y.
Flip the sign of the y. Flip the sign of the y. Yep. Now, right 2. What do you do if you're moving right 2? Add 2 to x. All right, so let's add 2 to x. Come on. Add 2 to x. -1 plus 2?
1, 2,
plus 2?
3, 4.
What do we do to the y? Switch the signs. Plot the points. Plot the points. Not even going to ask what that was. We're almost finished with graphing. I know. The other one's not going to fit. We have questions. Now, what kind of asymptote do we have? A horizontal. Is a horizontal x equals a number or y equals a number? Y equals a number. What number? 0. So your horizontal asymptote is y equals 0. Now let's talk about in behavior. Okay. As x approaches negative infinity. Look, X is going this way. The y values are getting closer and closer to 0. As x approaches positive infinity, so as x is going this way, what are the y values doing? Going to negative infinity. So there's your end behavior. Do you have questions so far? Don't get too excited there, Hayden. Now, what do you think, bud?
So it's going to be 3 times.
What are the transformations? What does this 3 do? Vertical stretch by a factor of, so you're going to write vertical stretch by a factor of 3. I can't read this. What does that say? X minus 1? What does that do? Right, 1. What does that do? Up 2. How many transformations do we have? Not quite. 3. Now, let's just think for a minute. You tell me this. What does a vertical stretch by a factor of 3 do to x or y? Multiplies the y by 3. Good. What does right 1 do? What does that mean to x or y? Add 1 to the x. What does up 2 do? Add 2 to the y. There you go. Add 2 to the y. Now, that's a lot. So what we're going to do is we're going to let the calculator do the work, and we're going to let the calculator give us our table. So go to your calculator. Go to your calculator. Oh, well, snap, dummy. That's not what I wanted. No, I'm talking to myself. I'm talking to myself, dear. I'm just going to say that you just took the walk of shame because you didn't have a calculator. Okay. What you're going to do is you're just going to type in that equation just like it is on your paper. 3 times, I can't even remember what it was. What is it? 2 to the x minus 1? You need to get in your calculator look just like that. Now here's what I want you to do. I want you to go to your window, but I want you to do table set. So how do you get this table set that's up here? Second window. Now we're going to use -2, -1, 0, 1, 2. All right? So we want to start our table at -2. And we want, delta table means how do I want to count? Do I want to count by ones? Yep, I want to count by ones. Now go to table, which is second graph. And what I want you to do on your paper, hey, you'd be happy I'm not making you do this by hand. I want you to put these in a table on your paper. Okay, so you have written those points on your sheet and you have plotted those points, correct? Tell me what the first point was. -2, 2 point, -2, 2.375. Keep going. -1, 2.75. Keep going. 1. And then 5. 1, 2, 3, 4, 5. 2, 6, 7, 8. Now you plotted those points. Now remember, that's an exponential. So an exponential's got a horizontal asymptote. Where is it? Why is it y equals 2?
Because it never goes below.
Near the x-axis.
Because it used to be on the x-axis, right?
And you moved it up.
And we moved it up 2. So I want you to dot in your horizontal asymptote. Are you making fun of the way I talk?
Can't even make a funny joke anymore. No,
I'm okay. I'm not offended.
okay.
I'm not offended.
I'm just a goober.
You get offended when you call her bruh.
I think it's just when you call her.
Answer by bruh.
I do not answer to a student by bruh. Okay? So your horizontal asymptote is at x equals or y equals? Y equals what?
2.
Y equals 2. Let's do your end behavior. Hayden, I agree. Please just hush. As x approaches negative infinity, what do the y values get closer and closer to? To 2 this time. And as x approaches infinity, also approaches infinity. There you go. Approximately 5 billion years. Well, that's a long time, but
Got about 10 billion more to go.
let's just do C.
Yay.
So we'll skip B.
Drop down 5.
We're best friends again.
5 billion.
What are the transformations on C? What's the 1/2 do? Vertical shrink or compression. So we'll do a vertical shrink by a factor of 1/2. Hey, go work.
Plus 3.
Okay, stop right there. What does that do to your graph? What does it do to x's or to y's?
Y is divided by.
That's right. The y is divided by 2 or multiplied by 1/2. Yeah, either way. Well done. What's that do? Left 3. Now, left 3. What does left 3 do to x or y? Subtract 3 from x. Good. Whoops, sorry. And then the plus 1 you said? What does that do to x or y? Moves the y up 1. Now, I want you to go to your calculator, graph that, and let's find your points. Please use alpha y equals whenever you want a fraction. X plus 3 or minus 3 plus 1. Make it look like that on your screen. Have you got your points? Hush. Hush. Now, not much of that's going to fit, is it? In fact, what's going to fit? The -2 and the -1. That's all that's going to fit. But you know this is an exponential, right? You know it's an exponential because there's an x in the exponent. So you know it's going to go either like this, woohoo, or like this, woohoo. Is that okay? -2, 3, and -1, 9. -2, 3. Oh, mercy. -2, 3. Come on, Stennett.
I don't know if this is right, but I feel like this is not right.
Was that -2, 3? And -1, 9?
Yeah.
4, 5, 6, 7, 8, 9. And then 0, whoo. Now, so what we've got to do is we've got to figure out, take your calculator. Let me show you something. Take your calculator, and I want you to use your up and down arrow key. Use your up arrow key one time. That point will help us. What's 3/2? 1.5. Add that to your list. -3, 1.5. So -3, 1.5. I'm not going to draw that quite yet because I'm not quite sure. Where's my horizontal asymptote? Why is it y equals 1 this time? Because it was at the x-axis, but it got moved up 1. You dot that asymptote in. It's right here. Now you know what that booger looks like. Looks like this.
Don't like boogers.
What's your horizontal asymptote? Y equals 1. Good. Now let's do your end behavior. Okay. I don't want words coming out of your face. I want stuff coming out of your pencil. Okay? Come on.
I'm thinking this looks like probably 1 to 2 negative infinities.
As x approaches negative infinity.
What did I?
1.
You said -1.
I
You-
said 1.
You said it. The way you said it was odd.
1 to negative infinity.
It meant
There's not, I know what you meant. It's not what you said. 1 to negative infinity doesn't,
Right there.
as x approaches it, would you shut up? As x approaches infinity.
Infinity.
Those of you who are new to me, Aiden and I have known each other for a long time. So, all right. Too long. Too long. Okay, I forgot to record. We're going to start this. We don't have very much time. The only homework you will have tonight is if you did not finish those 3 graphs. If you have finished those 3 graphs and checked them, make sure you have them turned in. On your table of contents, let me find it. On your table of contents, did you have on page, please be quiet. Okay, so page 97 on your table of contents, put 97 transform logs. Put that for your page 97. So we will finish our graphing tomorrow, okay? Yeah, that's about all we're going to get. Now, here's the issue. Do you see how small that page is that you're putting in your booklet? I mean, that your booklet is? It is so small. There is no way that you can do what you need to do. So here's what I'm going to suggest to you. Do the work on the graph paper that I gave you. And once we're finished, I'm going to have you staple it to the inside of your booklet, okay? So I'm going to have you just staple it like on one end. That way you can fold it up, okay? So please do the work on your graph paper. Now, on your first one, you just put A and then write f of x equals log base 2 of x plus 1 minus 2. Now I want you to take a look at this and I want you to decide first, Gavin, come back to your place, please. What are the transformations in this equation? What's that say?
I mean, left one.
Left one. All right, Sarah.
Oh my, I'm sorry.
Left one,
Down
down 2. Left one, down 2. Are you okay there? Now, here's what we're going to do. We're going to take this off. Now, whoops, not that way. Yeah, so I want you to do this. Our parent is y equals log base 2 of x. Now, if we can figure out how to graph that, then we can move left 1 down 2 and have the actual problem graphed, correct? Now, you can't put it in the calculator. You don't know how, and I'm not going to tell you. And because in some of them you can't right now. Okay, what we've got to think about is how did we graph logarithms before? Okay, I'm going to remind you how we did it before, but then I'm going to show you another way. Do you want me to show you another way? Because I needed to see, there are two different ways you can graph logs. I showed you one, and I wanted to see how you did with it before I decided if I was going to show you the other one. And I think I better show you the other one. Listen, graphing logarithms is probably more complicated than most of the other things that we do. But you can still do it. Rewrite this as an exponential. Just do a rewrite. Don't find an inverse, rewrite. 2 to the y equals x. Do you buy that? So 2 to the y equals x. Now, folks, these are the same thing. They are not inverses of each other. They are the same thing, just one written as a log and one written as an exponent. Are you okay so far? Now, if you'll notice here, what do you see in the exponent? The y value. So, if you remember, now this is the other way to graph a log. If you remember, what we did before was we let x equal -2, -1, 0, 1, and 2, but that was because the x was the exponent. Now let those be y because y is the exponent. Do you understand why I let those equal y? Because y is the exponent. Now, 2 squared is 4. 2 to the first power is 2. 2 to the 0 power is 1. If you plotted those points right there, ladies and gentlemen, you would have that log. That's what you would be graphing. Now what we have to do is apply the transformations. So we are not going to have time to do that, but listen to me. As soon as you get in here tomorrow, you're going to turn in those graphs if you have not finished them. Get this out, and we're going to get started, okay? Tomorrow should be the last day that we spend graphing.